Problem number 17. Paul and a giant stands outside on a force meter calibrated in newtons, which reads 5000 newton. Paul is wearing a large cowboy hat, which has horizontal cross-sectional area A equal 1 square meter, and completely covers both him and the scale when seen from directly above. At time t equals 0, rain begins to fall vertically downward on Paul, and any rain that hits his hat is collected in the hat's brim. The raindrops have a constant downward speed of 1 meters per second, and the rain accumulates on the ground at a rate of 1 millimeters per second. What is the reading in newtons on the scale as a function of the time t more than 0 in seconds? The density of water is 1000 kg per cubic meter. Solution for problem number 17. The force on the scale has three components. First, Shrek's weight. Second, the weight of the water collected in the hat. And the third, the pressure associated with changing the momentum of the downward falling rain. Component first gives a constant weight of 5000 newtons. Component 2 is equal to the weight of the water collected in the hat. The total volume of water collected is rate R, which is 1 millimeter per second, multiplied by time, multiplied by area of hat, multiplied by water density, and multiplied by G, which is finally 10 multiplied by T. And component 3 can be found by noting that in time T, the total mass is equal to rate of changing mass over time delta T, which is dm over delta T, multiplied by speed, which is Ra rho V, which is 1 Newton. So it means that total reading of this scale equal F1 plus F2 plus F3, which is 5001 plus 10T, which is answer B. And that was solution for problem number 17. Problem number 18. A massless rigid rod is pivoted at one end, and a mass M is at the other end. Originally, the rod rotates frictionlessly about the pivot with a uniform angular velocity such that the mass M has speed v. The rotating rod collides with another mass M at its midpoint, which then sticks to the rod. After the collision, what is the kinetic energy of the system? Solution for problem number 18. Here we have angular momentum conservation. It means that initial angular momentum mvr must be equal to this expression. So from here we can find that v final for first mass equal 4 over 5 v. Now we can count what is the final kinetic energy of this system. That will be kinetic energy for the first mass, which is 1/2 m v final square, plus kinetic energy for another mass, which is 1/2 m v final over 2 square. And finally that's equal to 2 over 5 m v square, which is answer D. And that was solution for problem number 18. Problem number 19. A system of cylinders and plates is set up as shown. The cylinders all have radius small r and roll without slipping to the right with angular velocity omega. What is the speed of the top plate? Solution for problem number 19. Instantaneously, each cylinder can be thought of as rotating about its point of contact with the ground or plate below. The rotating angular velocity is omega. This means that relative to the bottom of the cylinder, the top is moving at speed 2 omega r. So the first plate is moving to the right at this speed 2 omega r. The second plate moves to the right at 2 omega r faster than the first plate. And the top plate moves to the right at speed 6 omega r. That's answer E, and that was solution for problem number 19.